is Elsa, and I'm going to talk about my summer research experience with nanomaterials. So, oops, I need to go back because I clicked twice. Sorry. So this is me. I'm a third-year environmental engineering student at The Ohio State University. I'm also having a Chinese minor. And I worked with Dr. Lenhart and Jibin Liu in the Environmental Engineering and Biotechnology Research Lab, which is in the basement of one of the halls on campus. So the title of our project was the heteroaggregation of silver nanomaterials with clay in an aqueous environment. So that's a lot of big words. So we're going to break it down. What I want you to focus on is the nanomaterial part of this. So what's a nanomaterial? This right here is a TEM image of nanosilver. So those little dots that you see on the screen, that's actually the nanomaterial that we were working with in my lab. And the scale of this, how many of you know how big a virus is? Tiny, right? This is 10 times smaller than a virus, okay? So we're talking really tiny, can't even begin to see it with the naked eye. Okay, so why do we do nanomaterials? Why are they important? Well, when you synthesize these materials, you end up with a lot of special properties. So with silver, I'll talk a little bit more about that on the next slide. Nanomaterials like silver, with their special properties, are being used in a variety of commercial products. So in shampoos, conditioners, and nanosilver in particular is used in clothing, in athletic wear. So socks that you might have bought a month ago, a week ago, might actually have nanosilver. And the reason for this is that nanosilver is actually an antimicrobial agent. So it kills bacteria, anything that's really small that it can interrupt. It will get rid of that so you don't end up with those smelly socks after you work out, right? So the problem with this is that we don't actually know what happens to these when they're released into the environment. So when you wash your socks, it goes into the water, and the water goes into the sewage, ends up in a river or stream. What happens to it then? No one's really done this research, so we decided that it was a good place to start. So we use this DLS machine, dynamic light scattering, to check this, in our research. So first off, we had to check the status of our nanomaterials which we synthesize in the lab. So you have to make sure that nothing went wrong with the synthesis. So we look at the sizes, make sure they're similar, and that all exhibit the similar properties. And we do the same for our clays, which we also make in the lab. And then after that, once everything's good to go, we mix them together, and we use the machine to look at the sizes of our final product to see if one bit of nanosilver and one bit of clay actually go together. So an example of one of the results that we get back looks kind of like this. So in the top you see the effective diameter. So that's the feedback that we're really looking at. So this one, 73.2 nanometers, is actually the size of one nanosilver particle. So, and then the clays are about 300, and then we get a mix of values for when they're mixed together. So we do 10 runs, so it takes 10 different measurements, and we just make sure that so for this one we were just checking to see that all of them were about the same size, that it wasn't too big, too small, and then we moved on to the other ones. So our goal with this is to find out that if the clay and the nanoparticles go together, then the nanomaterial is being transported with the clay in rivers and streams. So it's going to end up in riverbeds, and then from there we're going to look into how it evolves once it's in the environment. So that's the next step. Thank you very much.